Hey guys, Jay Wise here from Cruise Integration. We're a system integrator. We've been around since 1992. We deal with control systems, and database systems, and reporting and data collection systems for many industries: steel industry, food and beverage, pharmaceutical, alternative energy, textile, security. One of the niches we got into in about 1995 was the dredging industry. We brought a lot of the technology that we've learned from all these other industries into the dredging, and we've done a lot of trade shows since then. We've done a lot of articles in magazines. Of course, we do a lot of advertising in the magazines as well, and also do presentations from some of the work that we've done. Specialty projects we do for the dredging contractors as well as dredges in the aggregate industry. Work with a lot of the dredge manufacturers as well, so it's one of our big niches. And I've been keeping in touch with the Silent Inspector all the way back from 10 years ago, and finally found it's going to be rolled out this year as a DQM. So back in October 2016, I started getting interested in really being able to support and be able to tackle this and give information to the DQM through our systems, non-proprietary, off-the-shelf software without additional hardware. A lot of the dredges that you're going to be working with already have PLCs on them, already have instrumentation on them. I've looked at something on the Dredge Potter before, and I saw that there was a lot of proprietary software on there, a lot of intervening, a lot of support for the system, extra hardware that needed to communicate to the serial interface when PLCs already existed. So I started thinking, well, we can do this a lot easier because we do this every day. So the software package that I developed is actually using off-the-shelf software called Wonderware. It's the industry worldwide standard for HMIs, human machine interface. The nice thing about that is that it has the drivers already for communicating Profibus, Modbus, OPC, and to any PLC. So it's already open. We don't need to go out and start experimenting. In addition to the open software that we're using, the HMI software, we also didn't want to have to hold the contractor to a certain positioning software package. So we developed our own web-based interface to any GPS through serial or through Ethernet, and it allows us to collect all the pertinent NEMA string data that's necessary per the DQM specs. Let's get started and show you what we have. After spending days and days reading through the Army Corps spec, getting very familiar with it, it comes down to the components is that the Army Corps will be supplying, actually the contractor will be supplying the computers per the spec, but the Army Corps will be putting their software on there. The contractor is also going to be responsible for putting a ship server. And of course, the ship server is what collects all of the data and the events that we'll be discussing here in a moment, and sending it through a data serial link to the Army Corps software. Now, what we've set up here since October, I've been working with the Army Corps. The dredge specific system is going to be this computer over here. It's literally a laptop that I have given access to the Army Corps, and in fact, if you guys need to get access to it again anytime, here is the TeamViewer code. So I'll leave that running if you need to access this. All right, so that'll stay online for you all to be able to intervene if you need to. The only thing on here right now is running is your software. You can see your different tabs up here. One of you gentlemen installed this for me remotely. So we're going to look at the raw JSON strings, because according to the specs, I bring everything in to your software through the serial port, from our computer. All right, so this is the computer and the software I will be supplying on a dredge. And by the way, our software is non-proprietary, open architecture. We're using off-the-shelf Microsoft software and an HMI package, which is the most popular one, Wonderware, you can find in the world. So the nice thing about the Wonderware, the interface we're using, is unlike one of the interfaces I saw on the Dredge Potter, which they're putting on many different serial interfaces, our software will communicate with any PLC It has drivers to communicate with any PLC, so it takes advantage of the PLC system and the instrumentation that's already on the dredge. In fact, if a dredge does not have a PLC, I could simply install this $350 device, which will work. It takes analog input, all 8 channels, so it'll bring in all of your instrumentation that you need and give it give it Ethernet up into this computer so that there's no proprietary hardware in the field. Don't need all these different serial devices that I've seen on some people's systems. So that makes it very, very simple, very lightweight, and anybody can do it. I could probably spend a day on a dredge installing the entire DQM system, not weeks, and not a lot of support. Especially if it's a PLC, I could do it remote. So anyhow, the things that we're going to need is we need an interface to the NEMA string, regardless of the receiver, the GPS receiver. So I made this interface. It's actually, it runs off, you can see it's just a web browser, and it communicates either through the COM port or through Ethernet. So many of the popular GPS systems will give up information either way. So anything that's necessary out of the GPS, your latitude, longitude, your height differential, your heading, your actual UDC time, and your cutter easting and northing, all that information comes through this software package here that we developed. So it does not require any one specific positioning software. It'll work with any one of the different software packages out there, not requiring you to have any name brand. So that's one software package. The next is, this right here is a test developed, which is running right now. I've got the work event that you guys specified is actually a lot of analog data. So here's your analog data, your depth, your slurry. All these values are actually just being changed from the PLC over here. PLC has just got a random generator in there because we're not really hooked up to a dredge. So we're given random information that's changing. Now, of course, per your spec, we average each one of these values, and then we send a trigger. You'll see this pop up about every 8 or 9 seconds right there, work event triggered. So it's automatically being sent through the serial port to the JSON string. Now, if you watch on your own software, you'll see this about every 8 or 9 seconds, you'll see your string update. All the instrumentation is actually updating and changing. So now, with our software package, you can actually enter in any of your comments. And you can also, for example, all of your other events. This work event is automatic every 8 seconds. The other events, you fill in the information, the contract number, the event type, all per your spec, the comment. And then you hit contract trigger, for example. Once you fill that out, if you hit the trigger, and I watch over here real quick, you see that it triggered. And now the next trigger will go right on back to the work event trigger because it's constantly updating. So each trigger, now I can trigger the pipeline event. If I click on that, watch over here, the JSON string gets the pipeline event, and then it goes right back to the work event because that's constantly updated. I can update the booster information, click on booster event, come over here, and the JSON string sees the booster information. And then as soon as the work event just takes over after a while because it's keep on triggering. And then we have advanced event, how far you advanced. You'll see over here the JSON string got sent to your software, and there's the information. We also have outfall trigger. Click on that. So really no one needs to enter any information in your software. We're sending all that to your software package. And your downtime. Now, one of the nice things about the downtime is that we've already had downtime information. On all the computers that we install, and on this one, we have Microsoft SQL. Now, with the SQL, the operator can log in, and when the machine goes down, when the dredge goes down, a pop-up comes up and allows him to select the reason he's down. So he doesn't have to be typing a lot of information in. Supervisors can do that in the background. And then the information, as soon as you hit save, it updates the function code and the reason, and it would automatically send that trigger, which you can see it ends up over here through your JSON monitor. So that's what we're doing. It's running. It's up and running right now. And you can log into your computer and see all the data. So it's been running since, it's about 2:22 now. I've had it on Wednesday, and I've had it running for about 2 hours now. And I've just been doing occasional event triggers. The other thing that we have on our software is calibration. All the instrumentation, we can do complete instrumentation plan for you, and we can certify it. We have a full crew of engineers to do calibration on board and keep everything calibrated. And from here, they can calibrate any instrument they change out, put in what the value is that's stamped on the transmitter for the 4 milliamps and the 20 milliamps. And also you can calibrate your ladder angle inclinometer here and your antenna offsets. You'd enter your information in here to the trunnion. So our system is completely independent of any positioning system. All right, thanks guys.